So, all right, we're recording now. And let me go to sharing the screen. All right, so we are here. The game plan is 1.7 and 2.1. No in-class assignment today. I'll probably finish early. Tomorrow, 2.2, and then the second quiz. And by the way, if I end up falling behind, I have lots of buffer days at the end. Like I set up my schedule so that I would finish 2 weeks ahead of time, which means I have roughly 6 or 7 days extra. Okay, so if I fall behind by a day or two, I'm still okay, so to speak. Okay. So I did very little of 1.6 yesterday. I'll knock off 1.6 and, sorry, 1.7, and then start 2.1. 2.1 is basically just quadratic formula, again, for the most part. And I'm changing the assignment considerably for 2.1. So please change 2.1. Okay, I'm still going to do 1 to 17 odd. Throw all of this out. I'm changing it to 55 to 58 all. That should be ALL. Okay, so it's a much shorter assignment. It's basically on the quadratic formula. Okay, so 2.1, 1 to 17 odd, 55 to 58 all ALL. Okay, so yesterday I did very little of 1.7, finish that off, then hopefully 2.1. Okay, and again, my goal is to finish early today and not give you an in-class assignment so I can go to my appointment. All right, so I'll go ahead and begin. As usual, if you ever want to ask a question and put it in the chat, that's fine. But I won't be able to look at it while I'm lecturing. Okay, so back to 1.7. We were starting to do symmetry. I think it got as far as 7. Okay, so 9 through 25. Let's look at what we got in our assignment. Yeah, we had to do 1 to 25. Okay, so graph the equation after determining any intercepts and whether the graph possesses any kind of symmetry. Okay, so how do you do that? Okay, so how about I start off with number 9, y equals 4 minus x squared. So this is 1.7, page 71. Whoops. Number 9, y equals 4 minus x squared. What does it look like? Let's get intercepts. Okay, so recall x-intercept means y equals 0. Remember what x-intercept means? Y equals 0. What does y-intercept mean? X equals 0. Okay, what happens when I plug in 0 right here? 0 squared is 0. 4 minus 0 is 4. 0, 4. All right, how about y equals 0? Put a 0 right there. 0 equals 4 minus x squared. Okay. You could factor. Let me do this by the square root property. I will add x squared to both sides. Again, this is my abbreviation for adding x squared. That means put the x squared over here. It changes to a positive. X squared equals 4. Do the square root property. Square root, square root. When you do that, you have to include a plus or minus. Don't forget. So x is plus or minus 2. So I have plus or minus 2, comma 0. And I'll raise it up only occasionally because I can't hold it all the time. All right, so I found my intercepts. X-intercept, plug in y is 0. Y-intercept, plug in x is 0. So we got 0, 4, plus or minus 2, 0. Okay. You might recall from your earlier work that this is a parabola. And the minus sign means it opens down. So it's going to be sort of an upside down U shape, like that. If there was a positive coefficient for x squared, it'd be going up. Okay, so let me plot 0, 4, plus or minus 2, 0. So quick graph. Just freehand. Don't go out and buy graph paper. Sorry. Try to uncurl the paper. Okay, plus or minus 2, comma 0. So 1, 2, 1, 2. There and there. And 0, 4. 1, 2, 3, 4. Okay, so here's 0, 4. Negative 2, 0, 2, 0. Raise it up a little. All right, I know it looks like this, right? It opens down. So I'll just connect them so it goes like this. And there's the graph. Switch it to yellow for some reason sometimes. Okay. Do you recognize any symmetry? Okay. Yes, it looks like we have symmetry with respect to the y-axis. Okay, so we have y-axis symmetry. All right, now I mentioned it quickly last time, but I'll go over it a little bit more. If you have certain kinds of symmetry, some things hold. Back on page 59, for y-axis symmetry. Okay. All of this says if you replace x by negative x and you get an equivalent equation, then you have symmetry with respect to the y-axis. Okay, so what does that mean? If we replace x with negative x, if we replace x with negative x, we get an equivalent equation. So that's a characteristic of y-axis symmetry. If we replace x with negative x in the original, we get an equivalent equation. Okay, so what does that mean in this particular case? Okay, so the original was y equals 4 minus x squared. Okay. If I replace x with negative x, it looks like this. Okay. So pretend you erase this x, put instead negative x in parentheses. Okay. But what is negative x squared? Yeah, it's the same thing as x squared. And by the way, in case you're wondering, this is not a double negative. Okay, this is really a subtraction. That's an exponent. Exponent has higher priority. So you get y equals 4 minus x squared. And you notice you get the same thing back as the original. Right? It's equivalent to the original. And so that's a characteristic of y-axis symmetry. Okay? If you replace x with negative x, you get an equivalent equation. Okay. So that's how that one goes. I don't know why this switches to yellow on me every now and then. Here we go. All right. Okay, I'm going to show you 15. Y equals negative 1 over x cubed. Negative 1 over x cubed. I'm not allowed to plug in 0, right? So forget that. And I can't put a 0 here either. Why? You already have -1 over something. A fraction is equal to 0 when the numerator is 0, right? But the numerator is already -1. What does it mean? Is that we have no intercepts. X equals 0. Can't happen. Y equals 0. Can't happen. Okay, so one more time. For intercepts, you plug in y is 0, x is 0. If I plug in x equals 0, you're dividing by 0. That's a mathematical no-no. I'm not allowed to plug in y equals 0 either, because if 0 equals a fraction, stop and think about it. When is a fraction equal to 0? Well, the top has to be 0. But it's not. It's already -1. So can't do anything with it. Okay, so how do I graph such a crazy thing like that? Well, let me just pick some points. Okay, so I'm going to go back up. Y equals -1 over x cubed. Well, I can plug in 1, right? So what happens when I plug in 1? -1. How about if I plug in -1? -1 cubed is -1. So I have -1 divided by -1, which is a +1. Well, how about 2? -2. 2 cubed, 2 times 2 times 2, 8. -1/8. -2. -2 cubed, -2 times -2 times -2 is -8. -1 divided by -8 is 1/8. Okay, that's probably enough for now. Okay, I'll just draw these points and then show you the rest of it. Of course, 1/8 is not that big. 1, 2, 1, 2, 1, 2, 1, 2. Okay, 1, -1 is like that. -1, 1 is here. 2, comma, -1/8. That's sort of like that. -2, 1/8 is like that. Okay, you could plot more points. You cannot touch the x or y axes. Okay, so this looks like it's going up, but how do you go up but don't touch this? Well, you approach it as an asymptote, so it looks like this. Same thing over here. I touch here and here. I can't cross the x or y axes, so I get real close to the x-axis and I get real close to the y-axis. If you were to plot more points, you would see that. So this is the graph. Okay, this is origin symmetry. Symmetry with respect to the origin. So in other words, 1, -1, and -1, 1, they reflect across the origin from each other. So do 2, -1/8, and -2, 1/8. Okay, you basically change both signs. Okay, so this one reflects like this, sort of, like so. And you get something equivalent all the way through. So we have origin symmetry. Okay, how do we categorize origin symmetry? So I show you that page again, if I can find it. Page 59, origin symmetry. So what they're saying is x, y, anytime x comma y is on the graph, negative x, negative y is also on the graph. That means you replace x with negative x and y with negative y. You get an equivalent equation. So let me write that down. So I have to write all this stuff, but also y with negative y. So if we replace x with negative x and y with negative y, you have to do both of them, then we get an equivalent equation. We get an equivalent equation. Okay, so to have origin symmetry, if you replace x with negative x and y with negative y, we get an equivalent equation. Okay, so how does that work in this case? Y equals negative 1 over x cubed. Okay, from here, change this to negative y, change this to negative x in parentheses. That means it looks like this. Negative y equals negative 1 over negative x cubed. Negative y equals negative 1 over negative x cubed. Negative x cubed, negative x times negative x times negative x is that. Two negatives make a positive, so 1 over x cubed. Now, multiply both sides by negative 1. Y equals negative 1 over x cubed. Okay, and that is equivalent to the original. So I got arrows going there. And let me raise it up again so you can focus on it better. All right, so y-axis symmetry, if you replace x with negative x, you get an equivalent equation. You can put all this on your formula sheet, on your cheat sheet if you wish. For origin symmetry, if you replace x with negative x and y with negative y, we get an equivalent equation. Okay, what's left out? Well, x-axis symmetry. And what do you think that one would be? We'll replace y with negative y. Okay, so let me see if I can find a problem like that from the homework. Okay. But as long as I'm on that page, let me show you that. X-axis symmetry. Okay. X comma y and x comma negative y would also be in the curve. So if you replace y with negative y only, and you get an equivalent equation, then you have x-axis symmetry. Okay. So let me see if I can find one of those for you. (21) y squared equals 2x minus 4. It's kind of a hard graph. Let me do the symmetry first. Okay. I claim this will have x-axis symmetry. It's just kind of like this. If you replace y with negative y, you get an equivalent equation. If we replace y with negative y, we get an equivalent equation. Okay. That's kind of easy to see. If you change this to negative y squared equals 2x minus 4. Okay. What's negative y squared? Well, it's the same as y squared, where y squared equals 2x minus 4. And once again, it's equivalent to the original. And let me raise it up for you. So I know I haven't graphed it yet. We will. So x-axis symmetry. If we replace y with negative y, we get an equivalent equation. So if I change that to negative y squared, you get y squared, so it's the same as the original. Okay, so x-axis symmetry. If we replace y with negative y, we get an equivalent equation. Reverse everything for y-axis symmetry. If we replace x with negative x, we get an equivalent equation. Then for origin symmetry, you have to do both of them. Replace x with negative x and y with negative y. It turns out we get an equivalent equation. Feel free to put all of these on your formula sheet if you wish. Okay, so now let's try to figure out the graph of this funny thing. Okay, y squared equals 2x minus 4. Let me take the square root. Square root means there's going to be a plus or minus. Right? So y equals plus or minus the square root of 2x minus 4. Okay, and I'll tell you what, since I already know I have symmetry with respect to the x-axis, I'm going to have x-axis symmetry, let me just work on a part of the graph where the graph is above the x-axis and then just do symmetry after that. Okay. Let's see. I'm not allowed to plug in 0 for x and get a real number. I'm not allowed to plug in 1. I can plug in 2. What happens when I plug in 2? 0. Right? Now, I mean, it might be kind of hard to come up with quote-unquote nice numbers. How about I'll plug in 10? So why to pick 10? Because I think it comes out nice. 2 times 10? 20. 20 minus 4, 16. Square root of 16 is 4. I really have plus or minus 4. That's really all I need. That's all I want. So let me show you a real quick graph of this. Okay, I got to go out to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plus or minus 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, now the square root function curves. So I have 2, 0, 10, 4 is like there. Okay, so square root functions tend to look like this. All right, and since I know I have x-axis symmetry, symmetry with respect to the x-axis, but then you put a mirror here, and you get the reflection over here. So there's 10, negative 4. So there we go. Okay, and there's one more of this kind of problem I'm going to show you. So I've shown you an example of y-axis symmetry. And if you replace x with negative x, you get an equivalent equation. X-axis symmetry. Replace y with negative y, you get an equivalent equation. Origin symmetry. If we replace x with negative x and y with negative y, we get an equivalent equation. Is there anything else? There is. I'll show you 19. And that's the last one of this type I was going to show you. Okay, 19, y equals x squared minus 2x plus 1. Oops, it's not y squared. It's just y, sorry. I goofed. Okay, this thing factors into a perfect square. Can you guess what's the perfect square? What do you square to get that? What do you square to get 1? 1. The sign matches this. If this is a minus, this is a minus. If this is a plus, this is a plus. Okay, x minus 1 squared, it's basically just x squared moved over to the right 1 unit. Okay, so I make a little mini table. I know it's a parabola opening up. I'll just pick 3 very nice numbers. If I plug in 1, 0. I plug in 2. 2 minus 1 is 1. 1 squared is 1. Plug in 0. 0 minus 1 is negative 1. But you're squaring it. So again, it's 1. It's a parabola. You might recall from your algebra parabola. It opens up. So this is probably all I need. Okay, let's see. 1, 0, 0, 1, 2, 1. So these are my intercepts. And you can see there's no symmetry. Okay, at least with respect to the coordinate axes. I guess you could say there's an axis of symmetry here, but we're not talking about that right now, right? If I reflect about the x-axis, I don't have any graph down here, right? So no symmetry there. And this is not a reflection across the y-axis, right? If we reflect, if I put a mirror right there, then I'm supposed to get something over here like that, but I don't. And it definitely doesn't have origin symmetry. Otherwise, I'd have to reflect across the origin and get a point over here. And this one should come over here, but I don't. So here's an example of no symmetry, at least with respect to the x-axis, y-axis, or origin. That also means all this stuff. If I change y to negative y, I don't get the same thing back. If I change x to negative x, put a little minus sign here, that's not the same as the original either. And if I do it to both of them, put a minus here and a minus here, whatever you get, it isn't the same as the equivalent. So this one has no symmetry. Okay. All right, that's as much as I was going to show you there. Okay, now I was going to show you 41 to 49, which deals with circles. Okay, let me check the chat. Somebody has something in the chat. Let's see, got it. Okay, so I think we're good. So now we're doing circles. Page 66. A little bit of theory, and then the formula. Here's a circle, figure 16. I'll raise it up a little, but the book's heavy. I can't hold it that long. You have a center, HK, a radius of R. So here's a point on a circle, X comma Y. So all the points on a circle are the same distance away from the center, which they call it R. So if I use the distance formula, which we saw earlier, square root of x minus h squared plus y minus k squared, I'm supposed to get R, right? So this is the distance formula for 2 points. So I could use this as the equation of a circle. We usually don't like it like that because we don't like the square root. Okay? So from algebra, how do you get rid of a square root? Square both sides, right? So if I square this, that big square root is gone. That becomes R squared. So now the equation looks like this. So bottom line, this is what we have. Okay, now, if you understood nothing about what I said here, that's okay. I do want you to know this, the result. Okay? This is called the equation of a circle with a center at HK and a radius of R. So x minus h squared plus y minus k squared is equal to R squared. Okay, it's on page 66. Put this on your cheat sheet if you wish. This is called the equation of a circle. The center as h comma k, then you go x minus h. Notice it's x minus h. So you change the sign of whatever this is, x minus h squared plus y minus k squared. So again, you change the sign of whatever this is, y minus k squared, equals, the right-hand side is not r, you have to square the r, it's r squared. So let's say the radius is 5, you have to put 25 here. Or the radius is 7, you have to put 49 over here. Okay, so this is called the equation of a circle in standard form. And then I'll show you how to do some problems with that. Okay, by the way, it works both ways. If they give you this equation, then the center is h comma k. You change the sign of whatever's here. So this is a minus, that's a plus. So that means if this is a plus, this is a minus. And the radius is not this number, it'll be the square root of this number. Okay. I know everything here might be kind of fuzzy until I do some problems. So let me do some problems. Okay. All right, so that would be 41 to 49 now. So we'll do some of those. Okay, so 41 to 49. There it is, in case you want to look at the video later and you never want to buy the book. Okay, specify the center and the radius and determine whether the given point lies in a circle. Okay, so there's only 2 problems of that type, 41 and 43. So which one's harder? Maybe I'll do 41 because it seems like they get bigger numbers. Okay. 41. X minus 1 squared plus y minus 5 squared equals 169. Find the center of the radius. And then after that, yes or no, 6, -7 is on the circle. All right, so here's the way it works for the center. You change this sign, change this sign. So that'll be 1, 5. Okay. If this had been a plus, you would make this a minus. Likewise for this. So the center is 1, 5. The radius is the square root of 169. The square root of 169 turns out to be 13. Okay. So the center of this circle is 1, 5. The radius is 13. Okay, on my calculator quickly, it's square root button. Square root button is over here on my calculator. 169, square root of 169, 13. That's it. Now, is this point on the circle? So I just plug in 6, -7, grind it out, see if I get 169. So if I get 169, the answer is yes. If I don't get 169, the answer is no. Okay, so put -6 here. Change y to -7. Oh boy, they're all negative. Well, that's the way it goes. Fortunately, when you square it, positive anyway, right? So -6 minus 1 is -7 squared. -7 minus 5 is a -12 squared. 69. You can use your calculator. Okay. By the way, you can use your calculator on any quiz, test, homework, and so on. Okay, -7 squared is 49. -12 squared is 144 equals 169. That isn't going to work, right? I can tell right away. I don't even have to do the whole thing. 9 plus 4 is 13, right? So the one unit has to be 3, but this is already a 9. So no. So this point is not in the circle. That's all.
Wait, I have a question.
Yes.
Well, won't it be 6 minus 1? So 5 squared plus 12 squared. So it'd be 169 equals to 169.
Let's see. Oh, I put in
Yes.
-6. I did. You're right. It's supposed to be 6. I put -6 for some reason. So I goofed. Okay, so that should be a plus. Okay, it looks like it's a yes after all. All right, sorry. 6 minus 1 is 5. So that's a 5. 5 squared is 25. And 25 plus 144 is 169. So I couldn't be more wrong, I guess. So yes, just because my eyes are blind, and that I put in a negative when I shouldn't have. Okay, so it's a yes. So anyway, you got to see an example of a yes and a no, I guess. If I plug in -6, it didn't work, but I guess 6, -7 does work. Okay, so fooey on me, I messed up. Okay, 45, 47, 49. Determine the center and the radius and find the y coordinates of the point where the circle intersects the y-axis. Y-axis means x equals 0. Okay, I'll do 45 and I'll do 49 and then I'll stop and then maybe we'll break after that. Now, how do I make this equation look like this? Well, I can pretend it's x minus 0. Now, when you actually do this problem, you don't have to write this out. You can just say, okay, I know it's 0, 0. And now it's equal to something squared. Okay. So I need the square root of this. What's the square root of the square root of 2? Okay, that's weird. But remember, when you take a square root, you're raising it to the 1/2 power. And then there's another square root, so that's another 1/2 power. Should practice this off. And then you can multiply these. 1/2 times 1/2 is 1/4. And 2 to the 1/4 means the 4th root of 2. It's kind of weird, I know. So this is what I have. Okay, so the center is 0, 0. Basically, anytime you see just x squared plus y squared, the center is 0, 0. and the radius is the 4th root of 2. It's not a nice number. It's a number times itself, times itself, times itself, giving you 2. The square root of the square root of 2. Okay. The second part of the problem says, find the y-coordinates of any points of any where the circle intersects the y-axis. Okay. Y-axis means x equals 0. So I plug in 0 right there. So 0 squared plus y squared equals radical 2. Y squared equals radical 2. Do the square root property. Square root, plus or minus. So y equals plus or minus. Well, we just did this. Square root of 2 means the 4th root. So plus or minus the 4th root of 2. Okay. So we have 0 comma plus or minus 4th root of 2, like that. Okay. That's kind of weird. All right, I only have one more problem of this type, but it's going to be fairly long. Okay, it involves something called completing the square. And I'll write that down. 47 and 49 are much tougher. 49 looks harder. So let me write down 49. And then I'll be done with that section after that. So 49, 9x squared plus 54x plus 9y squared minus 6y plus 64 equals 0. That doesn't look like anything we want, but the idea is, can I force this equation to look like this, right? Because if I can, then I just go ahead and read the center and radius off of that. Okay. It involves something called completing the square, which you had in algebra before. You may not have seen it in a long time, but that's okay. Okay, so it's going to take longer than a few minutes now. I wanted to take a break now, I guess, before 12 to do this. Okay. All right, so I'll do this after the break. Let me check the chat. Somebody put something in the chat. Okay, something about -6. Why is it -6?
Yeah, Umid already asked the question and you switched it.
Ah, I see. I wrote it wrong. Okay, I see. Okay. All right, so I think we're done. Somebody asked about the book. I should have given it to you from the syllabus. If not, send me an email for that. I mean, you should have it all along. Here. Okay, we will break now. Let me check the time. It's 11:56, so not quite 12. So how about let's start up again at 12:10? Okay, so we'll break until 12:10. I'll put that in the chat also. Okay, so start at 12:10. Okay. Okay, folks, it's 10 after, so let's go ahead and, so I'll finish this one last problem up, in which case I would be done with 1.7. 2.1 is just on the quadratic formula. You've seen the quadratic formula before. I'm throwing all this stuff out. Okay. Remember, we're not having a test on this here. We're having a test covering chapters 1 and 2. And that would be Thursday the 4th, it looks like. Okay. Now, even though we're having a test here, I may get started with chapter 3. Right, but that chapter 3 won't be covered in the test. So you say, what do I turn in for homework? Everything from here to here. Okay. Now that you've already seen one quiz, the same thing for quizzes, homework, and exams. You know, take a picture, click, 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 and email it to me. Okay. So as soon as I do this one last problem, I'm done with this. I'll do 2.1, which is just a review of the quadratic formula, and then we're finished. Okay. But this is a longer problem. Okay, so something called completing the square. So how do I do that? Okay. Let me double check that I wrote that correctly, because I'm not sure if that is correct. Yeah, I guess it is. Factor out the 9 from these two. Okay. So 9 x squared plus 6x. Leave a space. Factor out the 9 here also. And you'd say, how do I take out a 9? Well, you're going to multiply by 9 here, so I'm dividing by 9. What is negative 6 divided by 9? Negative 6 divided by 9 is negative 2/3. Leave a space. Throw the 64 over. Okay, now if this bothers you, think of what happened here. If you take out a 9, you're basically going 54 divided by 9. It's the same thing here. If I divide by 9, you go negative 6 divided by 9, negative 2/3. Or again, multiply it back out. All right, 9x squared plus 54x, 9y squared. And then what is that times that? That would be negative 18 over 3, which is negative 6y. Okay, now complete the square. Have to do something called half and square. Take half the coefficient of x and square it, half the coefficient of y and square it. Okay, remember doing that in algebra? So I want half of 6. So how much is half of 6? 3. Square it, 9. I put the plus 9 here. I'll change colors, that's in red. Sorry, I'm supposed to put an equal sign here. That's an equal sign. Okay, when I put plus 9, though, it's really adding 81. 9 times 9 is 81. So I'm going to add 81. Okay, so plus 9 to complete the square. But it's really 9 times 9, which is 81. Okay, do the same thing over here. Take half the coefficient of y and square it. So 1/2, whoops. What is 1/2 of negative 2/3? 2's cancel out. Negative 1/3. Square it. Negative 1/3 squared is 1/9. And 1/9. But it's really plus 1 because 9 times 1/9 is 1. So now it looks like that. Okay, half and square. Half of 6 is 3. 3 squared is 9. Half and square. Half of negative 2/3 is negative 1/3. Negative 1/3 squared is 1/9. Okay. But this 9 is really 9 times 9 or 81 to balance. Plus 1/9 is really 9 times 1/9 is 1, so I add 1. So I've done the same thing to both sides. Okay, now, both of these factor into perfect squares. So my pen seems to be running out of ink. In other words, I can write it like this. And let's see, that is 17 plus 1 is 18. Okay, so what is this perfect square? You just have to give me the square root of this, square root of this, keep this sign. Square root of x squared is x. Square root of 9 is 3. And the sign is a plus. Same thing here, the square root of y squared, y. Square root of 1/9, 1/3, keep the sign minus. Okay, we're getting there. Last thing is get rid of the 9 by dividing out the 9. So divide 9, divide 9. X plus 3 squared plus y minus 1/3 squared equals 2. Okay, so it's definitely a much harder problem. So finally, I got the equation to look like that. So I can read the center off. The radius is the square root of the right-hand side. Okay, change that sign, change that sign. So negative 3 comma 1/3 is the center. The radius is the square root of 2. And just leave it like that. Okay, and the last thing it says for this problem, find the y-coordinates of the points where the circle intersects the y-axis, which means x equals 0. So I just plug in x equals 0. Put a 0 there. 0 plus 3 squared plus y minus 1/3 squared equals 2. That's 3. 3 squared is 9. Subtract 9. Excuse me. 2 minus 9 is negative 7. And for real numbers, that can't happen. Okay. We can do it for so-called complex numbers, which we'll do shortly. But these we're graphing on a real number line, right? And an XY coordinate system where X is real, Y is real. Something squared can't be a negative 7 as far as real numbers are concerned. So we're finished. So the problem is totally done. Okay, so that was quite a problem. But we will tackle this even today. Okay. We have complex numbers, the I business. Remember that? All right, so I am now done with 1.7. 2.1 is all in a quadratic formula. It should be completely a review. Okay, this is a quadratic formula. These are the quadratic formula with the I business, the complex numbers, so-called. Okay, and I'll review that for you in just a moment. Okay. Okay, so let's take a quick look at the schedule. So it looks like I'm right on schedule for now. 1.7 and 2.1. Okay. So we're starting 2.1. Quadratic equations. Where am I now? Page 81, it looks like. The famous quadratic formula, page 83. Okay. So if you have an equation in standard form, ax squared plus bx plus c equals 0, the equation must look like this. If it doesn't look like this, make it look like this. And a is not allowed to be 0, otherwise you don't have a quadratic formula. And by the way, you wouldn't be allowed to divide by 0. Okay, and you've seen this before, hopefully. X is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Fortunately, if you don't have it memorized, you can put it on your formula sheet. Okay. Now, if we were meeting face-to-face, I'd make you memorize it. Your previous teachers probably made you memorize it. Okay. They told us, during the pandemic, make things a little bit easier for students. Okay. My way of making it easier is, if you don't have it memorized, put this on your cheat sheet. Okay. But this should not be new to anybody. You should have seen this in Algebra 1. You should have seen it in Algebra 2. And we're just reviewing it today. Okay, so I'll be doing some of these, and then we'll be done for the day. Okay. So let me write it again. X is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so 2.1. Here we are again. I'm not sure if I showed it to you earlier, but no harm in showing it to you again. Page 89, except it's in yellow now. So 1 to 17, I think you have it there. Okay, in the direction it says, give a calculator approximation. I'm not going to do that. You can do it if you want to. This is not a calculator class. You can punch it in your calculator if you wish. I'm not going to. And then 55 to 58, they want complex roots. 55 to 58, okay. Okay, so I'll do some of these. So we had 1 to 17. I'll do a few of these. How about I'll show you number 5. 2y squared minus 5y minus 2 equals 0. Okay. All right, is this already in standard form? Yes, it is. Everything on one side equals 0. So my a, b, and c are 2, negative 5, and negative 2. Okay. Okay. This should not be new to anybody. You should have seen this before. Algebra 1, Algebra 2, hopefully. All right. Throw it in the formula. So negative b. What is negative b? Positive 5, right? You change the sign. Plus or minus square root. B squared. What is negative 5 squared? 25. Minus 4ac. 4 times a, which is 2, times c, which is negative 2, over 2 times a, 2 times 2. There it is. Just grind it out and you're done. Okay. Let's see. This is a double negative, right? Negative times a positive times a negative. So that whole thing's positive. So I'm going to change it to a plus. I'll change colors. That's a plus, and that's a plus, right? So it's 25 plus 4 times 2 times 2 is 16. 25 plus 16, which is 41. So it looks like my final answer is 5 plus or minus radical 41 all over 4. And you can leave it like that. 25 plus 16. Okay. if you can break down the square root of 41, you should, but you can't break that down, right? So just leave it alone. Okay. And again, the text says, give a calculated approximation. I'm not going to do that. You can do it if you want to or not, but there we are. Mind you, this represents two solutions. 5 minus radical 41 over 4, and 5 plus radical 41 over 4. Okay. Now, what happens if the problem doesn't look like that? Then you make it look like that. Okay. Oh, 11. X squared equals 8x minus 6. That doesn't look right. So I make it look right. Remember that? X squared equals negative 8x minus 6. Positive 8x minus 6, sorry. Okay, so standard form, the right-hand side is 0. So I throw these two guys over here, which means change its sign. So it goes a positive 8x here, it becomes a negative 8x here, right? And a negative 6 here means a positive 6 here. Is that right? Now it's good to go. A is 1. Remember, if you just see x squared, you can pretend there's a 1, right? Maybe I'll put a 1 in red, meaning it's understood. B is negative 8, C is 6. Okay, negative B, positive 8, plus or minus square root. B squared, what is negative 8 squared? 64. Minus 4AC. 4 times A, which is 1, times C, which is 6, all over 2A, 2 times 1. There it is. I just grind it out. See, scratch paper, this is 64 minus 24, right? 4 times 1 times 6 is 24. 64 minus 24 is 40. 8 plus or minus radical 40 all over 2. Okay, here's an example where you should keep going. Say, how do you keep going? You might recall I can take out a perfect square from 40. What's a perfect square besides 1 that goes in 40? 4, right? Forty is 4 times 10. And now what's the square root of 4? 2. So 2 comes outside. Like that. And then I can divide 2 into each of these. So 8 divided by 2 is 4. And then over here, the 2's just cancel out. So 4 plus or minus radical 10. Final answer. Okay. So that's that one. I wasn't going to do, but I'll just show you the setup. Negative y squared minus 8y equals 1. Yeah. Okay, so I'm not really going to do it. I'll just set you up. Move this over. Looks like this, which is perfectly legitimate. I could do that. I don't want to do it. Can you guess why I don't like this equation? Everything's negative. Is there a way I can make them all positive? Multiply both sides by -1. So instead of the worst case scenario, they're all negative, I make it the best case scenario, they're all positive. And then I'll just say, etc. You take it from there. Okay, so if you ever get a situation where you have too many negatives or you don't like the negative, you can always multiply both sides by -1 and make it positive. Okay, actually, I always prefer to have the leading coefficient positive. Anytime I have a negative for y squared or x squared, I immediately multiply by -1. Okay. One reason for that is this is A. A shows up twice in the formula, right? There's an A right there and an A right there. Okay. So I'm going to have A twice. I don't want to plug in two negatives. I'd rather plug in two positives. Okay. So let's say this ever came out to be -2y squared. I would immediately multiply by -1 to get a positive 2y squared. Okay. It just makes the problem much easier. Okay. All right, so I think I've shown you enough of that type of problem. So do the same thing for the rest of these. Now, for the last set 55 to 58, all, so I'll do the even ones, 56 and 58. They say they'll have complex solutions. So 4y squared plus 8y plus 5 equals 0, 56. What's going to happen is you're going to take the square root of a negative. All right, it's already in standard form. That's nice. A is 4, B is 8, C is 5. Looks like anything else. Very nice, everything's positive. But what's quote unquote wrong with this? Let's try it. Okay, negative B by formula, where'd it go? Here. So -8 plus or minus the square root. B squared, 36, minus 4AC, 4 times 4 times 5, 4AC, over 2A, 2 times 4. Okay, so what is this? Scratch paper, 36 minus, see, 4 times 5 is 20, right? 20 times 4 is 80. 36 minus 80, I got a square root of a negative number, which is not real, but yes, we can keep going. So we're going to have that I business. -8 plus or minus the square root of 36 minus 80 is what? -44. All over 2 times 4 is 8. Okay, so you recall how this worked in your intermediate algebra? Take the minus sign out and make it become an I. Okay. Easy way to think of it is just bring it right in front like that, make it stand up as an I. -8 plus or minus I radical 44 over 8. Okay, so again, the square root of -44 is I radical 44. Maybe a little sidebar here. If k is positive, then the square root of -k is I radical k. I is the square root of -1 by definition. Raise it up for you for focusing. All right, that's basically it, except we're supposed to reduce this. 44 is 4 times 11, right? So -8 plus or minus I radical 4 times 11 all over 8. Square root of 4 is 2. Take out the 2. I radical 11 over 8. Square root of 4 is 2. And this problem just doesn't want to stop. We can actually still keep going.
Can I ask a
That's
question?
even. This is even and this is even. Yeah, somebody had a question?
Yeah, how did you get 36 when b was 8?
Okay, maybe I goofed again. 8 squared is 64. You're right. Looks like I messed up again. Okay. So this is all bad. 64. Actually, that makes the problem easier. 64. Thank you. So 64 minus 80 is negative 16. Ah, I like that better. Yeah, then I don't have to do all this stuff. And that becomes an I. Square root of 16 is 4. So we're not completely out of the woods, but we're getting there. Okay, so take out a 4 from the top. 2 plus or minus I all over 8. Okay, then cancel this, leaving with a 2. Okay, so negative 2 plus or minus I over 2. And that's that. All right, so it looks like I messed up again. Okay, 58, and then I'll call it a day. All right. This does illustrate something. X squared plus 100 equals 0. There's a reason why I'm writing it like that. X squared plus 100. They don't give me any x. So if they don't give me any x, can you guess what I'm going to put in as a coefficient? 0x. Then we're good. So A is 1. B is 0. C is 100. Okay. Now look at what happens. Negative b. What is negative b? Negative 0, but negative 0 is 0. I like that. Plus or minus square root. B squared. 0 squared, 0. Right now I got nothing. I like that. But now we got something. Minus 4ac. 4 times 1 times 100 over 2a, 2 times 1. So that's going to be what? Negative 400? And I don't even need the 0, right? Because 0 plus whatever, just forget about the 0. Plus or minus the square root of negative 400 all over 2. Take the minus sign out, it becomes an I. I radical 400 over 2. Square root of 400 is a nice number, right? What's the square root of 400? You could use a calculator. It's 20, right? 20i divided by 2 plus or minus 10i. So it looks like the answer is plus or minus 10i. All right, so that's basically just it, a review of the quadratic formula. Okay, so schedule I, I'm right on schedule, 1.7 to 2.1. If I start to fall behind, no worries, I got all these extra days, almost 2 weeks at the end, in case I mess up, I leave so-called buffer days. Okay, so I'm up to here, so tomorrow, 2.2, and tomorrow's Thursday, so I'll give you your second quiz. Now that you've seen the first quiz, they're all like that. I'll put you in the breakout rooms at the end of class, and then you help each other out, submit your quiz, and then I'll grade only one person's quiz from your breakout room. Okay. All right, we're done unless anybody has any questions. So anybody have a question, you can either unmute yourself or put it in the chat. Okay, wait just a moment. Let me quickly put the chat there. Okay, I don't hear anything and I don't see anything, so I guess we'll call it a day. All right, that'll do it, folks. Okay, so have a good day. We'll see everybody tomorrow. All right. Okay, bye. Have a good day, everyone.
Thank you. Have a nice day.
Thank you.